All right, well, thank you for joining us at our webinar today, Building an Automated Water Balance and the challenges we have in overcoming data silos and data availability in utilities and municipalities across North America and around the world. We are excited today to have Stan Fong, the CTO of Digital Water Solutions, lead us through this webinar and explain to you some of the challenges we've encountered, some of the things you can do, and how you can get to a point of having a water balance that's available to you in near real time. So Stan, thank you. Over to you to take care of the webinar from here in.
Thanks, Tim. All right, sounds good. Thanks, Tim. Thanks everybody for taking the time. Good to see some old faces here. Yeah, this is a good near and dear topic to my heart. Those of you that know us, you might know us for Hydrant.ai. We started to shift towards looking at what utilities are facing today, which is mainly this challenge with resources, right? Resource constraints, a lot of data, not a lot of resources, not a lot of capital to invest in new technology. So you need to find ways to do more with less, right? So we can see here, this is from a Black and Veatch report from 2024, surveying water utilities across North America, asking them, what are their main challenges, right? Rank them from top to bottom. And we can see aging infrastructures at the top. That's not a surprise. But some of the other ones that stand out, aging workforce, right? Funding, managing capital costs. So number 2, number 3, and number 5, 3 of the 5 pertain to resource constraints, right? And the bottom line again is that utilities need to find ways to do more with less. On the bright side, if we take stock at what's available, so from the 2025 report, you can see over the last few years, this is asking utilities in terms of the data you have available, how do you feel about the utilization, right? So we can see a couple things here. In 2025, right, 48% of utilities feel like they are collecting sufficient data. They've got enough data, but they're not really getting the most out of it. 28% feel like they're actually getting data and it's being leveraged effectively. Now, if we compare that to 2023 and 2024, you can see not much of a change between 23 and 24, right? It was 17% feel like they're using that data well, 19%. But there is a big jump between 2024 and 2025. And I think that that's indicative of this shift towards utilities getting on top of doing more with less, right? This is finally we're starting to see that come into fruition where we're finding ways to leverage this existing data. We're feeling better about what we're getting out of that data. And so that's why we also wanted to shift our focus towards helping utilities get to that point. And so today I'm going to go over, there's a bunch of things we can do with the data that utilities already have available, but one specific portion of that is, when we talk about the AWWA M36 Water Balance, how we can use, data that's available to most utilities and build something, as a basis for a water balance, and then what we can do beyond that. And I also want to talk about some of the challenges that go into that and how we were able to work through that with utilities. This is, what's standing in the way, right? So from that same survey, right, what's currently stopping a utility from doing this themselves, right? So you've got all this data, why are we sitting at this 48% of utilities still, basically half of utilities not feeling like they're getting the most of their data, right? If we look at what's at the top of this list, again, it's resource constraints, right? Number 1 is staffing resources, funding, legacy data. This is also just showing, so again, if we want to compare to the previous year, right, staffing resources is up 6%, funding up 2%. So these are becoming growing issues year by year, but legacy data and systems is down 10%, right? So again, I think this is indicative of utilities getting a better handle on the data they have. They're finding ways around it, whether they are bringing people in-house that can do it, or they're reaching out and working with third parties like us to basically take on the onus. It's a good trajectory that I'm seeing here, right? So you can see that in 2024, leadership and guidance was 35%, right? It's down 15%. So this is by far the biggest change between the 2 years. And I think that is, again, indicative of there's a direction now. Things are headed in the right way. What's new is IT infrastructure, right? So I'll talk about this more when we go to what problems are utilities facing when it comes to getting to that water balance, getting to leverage their data more effectively. This could mean a bunch of things, right? IT infrastructure could be the lack of it. You don't have the infrastructure available to, connect all the data together into a central location where you can leverage it with machine learning. Or it could also be that, your existing IT infrastructure makes it difficult to do what you want to do with the data, right? And we see both. And this is going to be a big factor when it comes to getting to the finish line. So, what obviously what you can do with that data, again, there's many things that you can do with your existing data, but today here we're specifically going to talk about this water balance, right? So most of us are familiar with M36 and the water balance, right? Pretty much an industry standard, this water audit. We can see, this is a big part of the reporting process, especially in the US, but here in Canada as well, right? We're using these guidelines to quantify how much non-revenue water we have, to measure different aspects of that non-revenue water. So this is the water balance itself, right? Taken from M36. And really what we're concerned about is this bottom chunk here. Today, at least, we're going to talk about a few things. One, the water supplied, right? So this is just flow into, if you've got DMAs, flow into the DMA. If you want to do a water balance at the DMA level. If you don't, then you're looking holistically at the system. What is the water coming out from production? And the flip side is billing data, right? Every utility has billing. Usually it's not real time in North America. And that's what we'll try to bridge with the machine learning, with the data science, is getting that real time. So you've got this flow data that is going to be real time. You've got the billing data that is typically not going to be real time. It's going to be meter reads that are done piecewise throughout the year. And then if I just take one minus the other, right, I get non-revenue water. So this is the basis. This is the simplest calculation we can do. And again, most utilities will have these two data sources. So if you're sitting there and you've got flow into a DMA, or you got flow into the system and you've got your billing data, this can happen for you, right? Beyond that, obviously, we can then calculate other metrics like minimum overnight flow and things like that to further dive deeper into the non-revenue water and break it down into parent losses and real losses. But as a starting point, this is all you need, right? So the second part of it is then, okay, we talked about two data sources. How do we get from asynchronous to real time? Because you've got this production that is coming in real time. Typically, your consumption, maybe it's updated every month, right? Sometimes every 4 months, depending on your cycle. So this is where we can use machine learning and data science. And I'll show that in an example, how we can convert that static data, the billing data, into real-time data so that you can get a daily estimate of non-revenue water. And then a couple other things you can do. Once this data is coming into the system, you can also use machine learning to monitor that data itself, right? So if you've got the flow data coming in, you want to know maybe when a meter is not reporting, if that's not available through the vendor software, you can set that up, right? You can be notified when you have gaps in that data, and that's going to lead to improved accuracy in the billing, right? So when it comes to both of these things, you're going to be able to improve billing accuracy. If there are derived billing calculations, let's say you've got a customer that is not directly metered, and you have to do a calculation to get the amount to bill that customer, and you do that on a regular basis, you can automate a lot of these things. So we've done that as well. It just saves time all around for your day to day. So let's talk about then what that actually looks like when you have this data. I've got my flow data, I've got my billing data. I want to go from the data to the data science and machine learning, in this case, the water balance. The first step is the data collection piece, right? So, things to ask yourself here is what types of data you have available. In this case, obviously, do you have the flow data? Is it accessible, right? Do you have the billing on hand? Is there anything that's missing? So this is less relevant here because again, we're looking at just the water balance, but you can apply this framework holistically, right? You could look at, look, if I want to get the most out of my existing data assets, start by thinking about what data assets you have, right? What's the availability of that data, the resolution of that data, as we call it. Are you missing any data that's going to be quintessential, right, to what you're trying to do here? This data aggregation step. So I've got all my data. Now I need to know, where is that data stored, right? Do you have any data silos? In other words, data that's just sitting kind of cordoned off from everything else. Identifying that and basically putting a plan of action into how do I rectify and how do I get the data out of that silo is going to be a big part of this. And what are your options for exporting this data? So going to each of the various vendor softwares and figuring out, is it just a CSV export? Do I have ways to automate the export of this data? If I don't currently, are there ways I can get an additional license for an API, for example, to export that data? Where are you going to put that data, right? So do you have a central kind of storage point in mind where you're going to feed all that data into so that these calculations can run? And then are there IT barriers, right? Do you have a SCADA system that is air-gapped, that is not connected to the internet? Do you have certain restrictions in terms of cybersecurity you can do with your data in regards to exporting and importing? So this is the most important step, right? Oftentimes we look at these problems and we go, oh, the data science and machine learning, that's all of the black magic and all the fun stuff. But this step is very quick, right? So when it comes to what we do here, it's fairly straightforward, right? To get this step done. Most of the time, I would say, almost 80% of the time of a project we're spending on the data aggregation step, right? And again, this is where it becomes the deal breaker, the non-starter for a lot of utilities, especially if you don't anticipate this or you don't know this ahead of time, right? You take on this project, you take on this initiative in-house, and then you run into this step, and then you realize, oh, this is not going to be feasible in the time frame that we allotted for this, right? It's not that that time is spent you're dedicated 40 hours a week. We're just grinding to make sure that we can get all these things connected. A lot of it is back and forth. It's dealing with bureaucracy. It's working with vendors individually, to basically work through these problems of, hey, I heard that, vendor A, you have an API that I can use to get the data where I need it to go. Okay, maybe that's not something I'm familiar with. I need to spend the time to learn about that. I need to connect with the vendor. Someone on their side maybe needs to pull a few levers and flip a few switches so that I can actually access that API. And you have to repeat this process for each data source, right? So sometimes it's a waiting game. So the sooner you get started on this, the better. Or you work with somebody like DWS to take this on for you. So we've basically been the point man for utilities. We basically take on all this for you, and we'll work with the vendors directly to get this data into the system where we need to go, and then we can set up the water balance part. So this part's pretty simple, right? What do I want to get of my data? In this case, it's an M36 water balance. What new insights can you get beyond that? And we'll talk about this too, but when we get the data coming in the system, we can also evaluate how reliable is that data, right? There's a lot that can be eye-opening in terms of that, the reliability of the data once you see it all kind of in front of you. And then ways to improve existing workflows. As we talked about, look, there's calculations that I'm doing on a regular basis. Can I automate that? Can I make predictions that are going to save me time in terms of not having to react to things, right, that are going on in my system, being able to be proactive about these things instead. Right, so this is all there just so that you can see it all in the proceedings. Now I want to spend time talking about the real meat of it, which is the case study. So over the last few months, we have been working with a few utilities on this M36 water balance piece. And this is not the actual utility. This is again just taken from, we use Fiji as our kind of test site, sandbox site. And this picture just kind of shows, we're dealing with a utility that's about this size. So the amount of area covered here, we've got one DMA, 7,000 services, closed pressure system, one pumping station, right? Two pumps. And what we get from that is we get a SCADA, a total cumulative flow every 10 minutes. Now, this is nice. They have all of their services are equipped with AMR, right? And the utility came to us thinking that they probably have a 20 to 30% NRW problem. Now, they also have limited budget for CapEx. They can't really afford to, install leak detection and things like that. And it's a very small utility, right? We're talking just a handful of people. So they're not going to have somebody that's going to be able to dedicate the time necessary to do the data aggregation to set up the machine learning. They don't have the expertise in that either. So, we came in and we wanted to set up this water balance for them. So let's look at the data that's available. Again, we just have two data sources here. We've got the total flow and we've got the billing. So here we can see the total cumulative flow. Again, we had to work with the utility. We had to work with the folks, the IT folks, to figure out what was going to be an appropriate solution to get this data out of their system and into the cloud. Right. So in this case, there was an SFTP secure file transfer protocol solution that we came up with that it was agreeable on both sides. And then we're able to get this cumulative flow data in real time. So you can see pump one, pump two, this flow data, right? From that, we can get flow rates. So from the total flow, fairly straightforward just to get the actual flow rate. So we can see here for the two pumps, right? You can see when one pump's on, the other one's off for the most part. And then after that, right, we can calculate a bunch of other useful metrics. So we can calculate minimum night flow rate. We can look at the total night flow, right? Basically, whatever you need for reporting purposes or for the existing kind of metrics or KPIs you track, you can get that, right? Once this data is coming in, it's fairly easy to set these things up. Very simple to calculate the flow over different periods. So if I wanted the total daily flow, I'm taking the area under the curve each day, 12-hour flow, hourly flow. Basically, we'll work with you in terms of you tell us what you need, and we'll be able to calculate it for you. But there's still challenges, right? So simple to calculate in theory, but there are things like this, data gaps, right? So we talked about reliability of data. So this data coming in, sometimes somebody knows that the data is not coming in, but usually not everybody that needs to know knows when there's missing data, right? So the question is, how do you deal with this missing data? There is a liability involved with that. Obviously, we can use machine learning to estimate, right, what this data is. But there is going to be, again, some liability that needs to be discussed. So there's different solutions available in terms of how you deal with this, right? We could leave it. We could then wait for the data to backfill, or we could try to estimate it. But it's important that the person making the decision, right, with this data is fully aware of, what is real data, what is synthetic data from machine learning. And all of this has to be addressed, right, when you're setting up this balance. So again, this is something that we'll look at each data source, we'll evaluate how reliable is that data, and then we'll come up with some solutions that we'll put in front of you and say, hey, this is what we can do, right? When you have this missing data, it could be that, look, we send an alarm to someone on your team who's responsible for that data. They're able to look at it. And then if they can typically get that data back in a timely manner, no need to create any synthetic data. We'll just wait for it to backfill. So the production is fairly straightforward, right? Apart from, dealing with these issues with reliability and things like that. When it comes to consumption, so I mentioned that this utility has AMR set up for all of their meters, 7,000 meters. They use that vendor's dashboard to view this data. So that dashboard doesn't allow for a real-time export of this data, right? You can get that through the API, but it comes at an additional cost. So the utility, again, they weren't aware of this API. They don't have anybody that knows how to use the API. So this is one where we worked with the vendor directly, right? On behalf of the utility, we're able to reach out to that vendor. The vendor themselves, they have not seen a lot of people use the API. So there are some hiccups to kind of work through there. But again, this is a data aggregation challenge, right? This is not anything to do with the machine learning and the data science. This is purely back and forth in logistics in regards to how can I get the data out of the system and into where it needs to go in the first place. So this process probably took, I want to say, 2 months, right? This process, and again, it's not 2 months, 40 hours a week. It's, 2 months, one email, waiting for a response, not the right person, find the next person, set up a call, next steps, right? That kind of timeline. So, this is something that, again, the sooner you started, the better. But this basically took 2 months. Getting all this stuff set up and dashboards and calculations, that can be done in a day, right? So it really puts into perspective where the actual kind of critical path is for these projects. So we get this data in the system, right? And then again, we talk about let's look at the reliability of this data. Let's do an initial kind of overview of what we see coming from the data. So you can see here the meter data. We've got about 6,314 meters that were available. So through that API, we can grab data for 6,314 meters. Not all the services are actually active, right? So we're going to assume here that these are the ones that they're actually active in billing. And we can see some inconsistencies in the reporting frequency. So what this chart is showing is that of these 6,300 meters, that only 5,500 or so report at least once a day. So if we're talking about setting up a water balance that is giving you a daily kind of NRW reading, right? Only about 70% of those meters are going to be reliable enough to do that. 819 meters don't have any data whatsoever, right? So breaking that down further, we saw about 470 of them are in meters that have known cellular coverage issues. So those are ones where the utility might know about, and they'll have to send someone out to basically read that meter manually. 348 of these, no idea, right? The utility doesn't know in terms of, why these meters are not reporting. For all they know, they should be reporting. So this is just showing some examples, right, of what that looks like in terms of here's the different days between August to October, and we can see this is the number of points that these meters report each day. So some of these meters, they report very consistently, right? This dark blue one is reporting 10 to 12 points a day, more than enough. Again, you just need one reading a day really for the meter. Some of these meters reported for a bit and then stopped, and then it comes back, right? Some reported for a bit, have not reported since, and some intermittently report, once a week or so, right? So it's very inconsistent. And this becomes a big problem because it depends on what is visible to you as the utility when you're viewing this dashboard. So if I look at this with this information in hand, I can interpret, I get a daily total consumption from that dashboard. I can interpret, oh, okay, I know that that only corresponds to, 70% of my meters, right? On the dashboard that the utility was using, that's not visible. So what that means is on a given day, we saw that only about 70% to 74% of the meters are going to report data. So the right hand side here, this y-axis, this is the percent of meters that are going to be reporting. That's this green dotted dashed line here. And this consumption value that's calculated, right, is going to be calculated from the meters that report. So the utility is viewing this blue line when they go into that dashboard and they see, okay, so this is how much water was consumed that day. I know how much water I produced, and then they're going to calculate their NRW based on that, right? If we do a quick adjustment, so let's say we just assume that, the missing meters that they're going to have a consumption value equal to the average consumption of all the meters that have reported, you can see the difference, right? 700 cubic meters of water is missing. So that's going to be a massive implication when it comes to non-revenue water. So right now, if I were to take just the reported data, right, and I calculate my non-revenue water, I've got the flow in, I've got the total flow, and then I've got my total consumption each day from the 70 to 74% of meters. I get NRW in the range of 25 to 30%, right? If I then calculate this, with that simple adjustment, again, we're just going to assume each missing meter has consumption equal to the average consumption. It basically becomes 0, right? Now, sorry, the actual NRW is going to be somewhere in between, right? This is a very simplified adjustment that we're making here. But you can see that this problem that the utility thought they had with NRW was actually less so a non-revenue water problem and more so a data visibility, data understanding problem, right? They were not aware of what was being reported in the data that they're seeing in the dashboard. If you're wondering what this dip is, actually, I go back, this outage, right? So no flow data was reported, was recorded during this period, and that translates, right, to this dip here. Right, and that's why it's important to be able to connect the dots with everything, right? So you understand, okay, well, this dip is not actually a leak being repaired or anything like that. It was due to, an outage in the production data. So again, the true non-revenue water is probably somewhere within that region. And what we can do with the historical data is we can get a better estimate from this. So with this meter data, the API that we're using only lets us grab, I think, the last few months of data. And what we had to do then is basically find, okay, well, how do we get more historical data so we can build a historical distribution, statistical distribution of meter reads, for each of these meters over, let's say, the last few years. From that, we're able to build, this statistical distribution of what the meter read should be, right? And from this, we can actually get a better estimate. So instead of just saying, look, every missing meter, we're going to assume that it has a consumption equal to the average. Well, in this case, we can actually get a more rigorous kind of backfill of that data. So that's going to be more dynamic. It's going to be more reflective of what the meter read would have actually been that day had you had that data come in organically. But again, this is a data aggregation challenge, right? We had to basically work and figure out how do we now get historical data out of the system. So bottom line, right, the implications of the non-revenue water is that the utility in this case may not have had as big of a non-revenue water problem as they initially suspected. And this is, again, an ongoing kind of project where, we go through the steps of setting this up with the utility. We share findings with them, and then they give us feedback, right? Maybe they were aware of some of this, maybe they weren't aware at all. From that feedback, we can basically inform, okay, well, what's the next step, right? Again, how would you like to fill in this data? What would you like us to do in terms of more insights from this data? Do you want to be alerted of things like, this reporting percentage, right, for the meters, and things like that. So we can set up alarms for that. We can, basically find ways to mitigate. But hopefully this gives you kind of a perspective in terms of, look, just dealing with two data sources here, right? Just flow and just billing data, the amount of overhead that is involved. Again, a lot of it just comes down to this data aggregation step. Going back, really you cannot underestimate how long this step takes, right? This last step is very straightforward again. We can competently do whatever you need to do with the machine learning in a very short amount of time. But getting the data, doesn't matter who you are, right? You're dealing with people, you're dealing with a lot of different stakeholders. Sometimes you're dealing with egos and things like that. And that's what takes time, right? So um, obviously what we do then is as we work with the utility, we're building that relationship with the various stakeholders, with the IT department and things like that, so that as we go on and as we work further into these projects, we're able to work through these barriers faster the second time around, right? So the next time we want to pull a different data source out, we have solutions that we know will work for that utility. We are familiar with the people that are responsible for signing off on X and Y, and then as time goes on, you're able to become much more efficient in setting up additional decision support tools from that data.
Great, Stan. So one of the questions is, when you show this, some of this would just be manually recorded data that they have, in their system. How can we start to break this down in an automated way to give them all of these different numbers? And is it even possible, or is it really just a bulk non-revenue water number at the end?
The bulk is the starting point, right? This is the easiest one to get, right? Yeah, because you're just taking the amount of water supplied, which that's usually the most straightforward kind of number to obtain. And then the amount you're billing, which is going to be a manual number for most people, right? So we can basically take steps to turn this manual number turn this into an estimated kind of real-time number from that manual data. And we can repeat that process for other data sources as well, right? So if you have some of these other numbers that are manually recorded, we could do the same thing that we're doing that I showed with the billing here. We can look at the statistical kind of historical distribution of that data, and then we can get an estimate. So it really does depend on the level of granularity when it comes to, again, what data do you have at the utility, and how granular is that data? So it goes back to that step one, right, of taking stock of what you have, and we can work with you to get some of these numbers, right? If you have the data there, yeah, we can make it happen.
Thanks again for joining us. We look forward to seeing you at the next webinar. Take good care.
Thanks, guys. Yeah.